Oh, they've changed the way it sounds. The creepy robot sounds different. Okay, whatever. This Zoom session is being brought to you by the Fractal Bullseye Bubble Water. Okay, for today, we'll be doing 6-1 and 6-2, meaning that we finished 5 last time, and so it starts to be, start handing it in on Wednesday. Anyhow, for this, solving linear systems by matrices, and 6-2 is about something called matrix algebra. All right, now a matrix, it's an array of numbers, a rectangular array of numbers. This one is 2 rows and 3 columns, so therefore it's called a 2 by 3 matrix. Any linear system has what's called an augmented matrix. For example, 1x plus 2y equals 6, 3x minus 1y equals -10. This is a 2 by 2 system. So we put the numbers 1, 2, and 6 in this first row of the augmented matrix, 3, -1, and -10 in the second row of the augmented matrix. Augmented because of this column 6, -10, referring to the numbers on the other side. This 1, 2, 3, -1, that would be a 2 by 2 matrix. That's called a coefficient matrix. We'll get to that later. We can solve linear systems by doing row operations, like with row operations with this system, by doing that on the augmented matrix. It's basically the same process, only you don't have to carry around the x's, the pluses, the y's, and the equal signs. It's just the same numbers being worked on more directly. So for example, here we go, 2x minus y equals -1, x minus 2y equals 1. First, we translate to the augmented matrix, 2, -1, -1 here, 1, -2, 1 here. Now we'll do the same row operations and the same pivoting on entries as before. For example, here we have a 1 here. We want to clear its column, basically remove this 2 in order to basically have only x be referred to in this equation. So, okay, we have a 2 here, so we subtract twice of row 2 from row 1. So 2 minus twice 1 is 0. We put a 0 here. -1 minus twice 2 is a 3. We put a 3 there. -1 minus twice 1 is a -3. We put a -3 there. Keep the second row the same. So 0, 3 minus 3, 1, -2, 1. All right. Next row operation is to divide this row by 3. So divide each entry by 3, you get 0, 1, -1. And the second row is still 1, -2, 1. Now, okay, now we'll pivot on this entry. In other words, clear away this -2. We'll do that by adding 2 of row 1 to row 2. So for example, 1 plus twice 0 is 1. So put a 1 there. -2 plus twice 1 is 0. So put a 0 there. 1 plus twice -1 is a -1. So we put a -1 there. Now, this isn't quite right in the proper form because this says 0x. If you translate back to the system, this says 0x plus 1y is -1, 1x plus 0y is -1. So to put it back in alphabetical order, x and y, we swap the rows. That's the row operation. So we get this matrix, 1, 0, -1, 0, 1, -1. This corresponds to translating back to the equation that gives us 1x equals -1 and 1y equals -1. So x and y are both -1, and it's easy to check that this indeed solves that system. So the idea is we use a row operations to get a matrix of the form 10A, 01B, which translate back to x equals A and y equals B. So for example, x plus y equals 2, x minus y equals 0. All right, so the augmented matrix is 1, 1, 2 for the first row, 1, -1, 0 for the second row. Now we're going to pivot on this one to clear out this one here. So subtract 1 of row 1 from row 2. 1 minus 1 is 0. There goes a 0. -1 minus 1 is a -2. There goes a -2. 0 minus 2 is a -2. There goes a -2. So the matrix is now 1, 1, 2, 0, -2, -2. This row, we rescale by a -2, dividing by -2. And so it becomes 0, 1, 1. So we have the matrix 1, 1, 2, 0, 1, 1. We'll pivot on this entry here and to eliminate this by simply subtracting row 2 from row 1. So 1 minus 0 is a 1, that stays a 1. 1 minus 1 is a 0, that becomes a 0. 2 minus 1 is 1, that's the 1. And there we go, 1, 1, 0, 1, 1. And so this translates back to 1x equals 1 and 1y equals 1. x equals 1 and y equals 1. Here we have x minus 3y is 9, minus 2x plus 6y is 18. So augmented matrix, 1, negative 3, 9, negative 2, 6, 18. These are all even numbers. Let's divide by negative 2. So you get 1, 3, 9, 1, negative 3, 9, 1, negative 3, negative 9. We'll clear on this by subtracting row 1 from row 2. So 1 minus 1 is 0. There's a 0. Negative 3 minus negative 3 is a 0. That's a 0. Negative 9 minus 9 is a negative 18. There's a negative 18. Uh-oh. Here's the problem. We've simplified it down, however, to where this row translates back to the equation 0x plus 0y equals negative 18. No solution. If you get a row where it's all zeros except for a non-zero in the last column, there's no solution. If the last row were 0, 0, 0, then you have a underdetermined system where there's not enough information. Only one equation's worth of information to find two variables. Okay, here we have a 3 by 3 system, and it's much the same thing, only about twice the work. So 1x, 1y, 1z equals 6, 1, 1, 1, 6, 1x, 2y, 1z equals 8, 1, 2, 1, 8, 1x, 1y, 2z, 7, 1, 1, 2, 7. Okay, we'll pivot on this entry here. So eliminate this one here by subtracting row 1 from row 2. Eliminate this one here by subtracting row 1 from row 3. And after the appropriate subtractions, we get this 1116, 0102, 0011. Okay. Well, we'll use this one here and this one here to clear away this. So subtract row 2 and row 3 from row 1. And after appropriate operations, you get 0003, 0102, 0011. So x is 3, y is 2, z is 1. That solves this system. And okay, here, this one, a little more troublesome just to set up the augmented matrix. 5x plus 3y plus 0z equals 4. So 5, 3, 0, 4. 0x plus 3y minus 4z is 4. 0, 3, negative 4, 4. 1x plus 0y plus 1z is 1. 1, 0, 1, 1. Okay. Okay, here's what we'll do. I'll use this one here to eliminate this 4. Add 4 of row 3 to row 2. Which after that happens, you get 4308 for row 2, 5304 for row 1, 11011, 1011 for row 3. Okay. Here, I do a slightly fancy trick. I subtract row 2 from row 3. That'll eliminate this and this. So you get first row, 5 minus 4 is a 1, 3 minus 3 is a 0, 0 minus 0 is a 0, 4 minus 8 is negative 4. So already we get x equals 4. Use this one here to cancel these ones. I get this matrix here. This row here is everything except as zeros except for 3y to divide throughout by 3, and we get this 10, negative 4, 0108, 0015. So x is negative 4, y is 8, z is 5. Okay, now that's this section.